Hello, welcome to all my combo lords joining me today in this awkwardly placed position in the combo classroom where our desk is a bit diagonal. You know, I have to be very careful if I let go of any items on the desk or they will slide back down, such as this coffee cup. But today I was joining you all in the combo classroom to celebrate a few things and answer a few frequently asked and freshly asked, if there happen to be people in the chat with any fresh questions. And this will be somewhat of a Q&A, although I will begin with just answering some frequently asked questions. And we will also be celebrating the fact that this channel, in less than 2 years, in fact, in about 20 months, passed 200,000 subscribers. A pretty arbitrary number on the big scale of things, but in our base-dependent system where we're living in base 10, it looks way cooler to have a 2 in front. So we've gotten there. Now, in my other main channel, that one progresses slightly slower because I don't put all the shorts on there, and so that is, I guess, the first frequently asked question is, why does your bonus channel have more subscribers than your main channel? Well, it's really just because of the shorts. I also do a ton of live streams on this channel, and I used to put out bonus videos, which I will continue to put out in the future. Recently, I've just been not wanting to edit much bonus content and been spending my editing time on my main combo class episodes, making some pretty long ones, including the next upcoming one on that channel, which will be maybe my favorite one yet. And I haven't said that before. I've said my favorite episode with some specification, maybe, but I've never said before that one was going to be my favorite episode yet. This one may be that, though, because it's about a topic. It'll be about 30 to 40 minutes. It's about a topic called integer complexity. I've mentioned on this channel before that I think is maybe the most underrated concept in number theory, and that I also have a personal journey to take you along of how I first discovered it myself and what led me to that name and such. Now, to answer some other okay, yeah, I gotta be careful with the coffee cups around here and such. Remember, we're on the tilted surface. There's not even that many clocks in the background because there's a rather large clock pile right here that has accumulated down at the base of the desk. Whenever we have the crooked desk, we get a zone that I nickname the vortex, and in the vortex is where all the things that slide off the desk end up. Here I also have a little basket of some of my favorite fruits, blueberries, that I will snack on while answering a few questions, but I'm going to set them down somewhere half safe as we can get at the moment, and be good for a moment. Now, to answer a few other frequently asked questions, yes, this channel is just my bonus channel, but it has more subscribers due to the shorts I've posted on here. We will see if shorts turn out to generate subscribers that stay along with the combo class learning program and continue along with my journey with me, or whether the short subscribers don't mean as much as the subscribers on the other channel that recently reached 40,000. I don't know, I'm the guinea pig generation for that in a way. We are testing this out in real time, what makes sense to have on what channel and to what degree subscribers you get from shorts end up benefiting you in the long run, and so on. In any case, make sure you're all tuned into the Combo Class channel, because I will really try to have the next episode out quite soon. There is a slight delay in the program, which I will answer one of the questions in the comments now, which is, how am I doing? And I'm doing pretty good because we have a lot of cool plans going and we've passed these 2 milestones. However, I did unfortunately... It's a long story, I'll explain later perhaps, but I lost my phone that I often use to film on. I have everything backed up off it, but I still have a scene or two to film for the next episode, and I'm not sure exactly how I'm going to film those tonight and tomorrow. Probably hooking up other webcam devices to my computer and hoping I can get a good enough shot through the computer like I used to live stream here. And so there might be this style of footage just for a little bit in that next episode because unfortunately my filming device is lost track of for the moment. I will explain more about that later or another time perhaps, but I'm doing relatively good at least, and the reason why we're doing quite good is because I've just been building these channels out of the dirt with a little help from friends and family and wildlife and animals and such. And out of this clock filled dirt and dice filled dirt, particularly, you see all those dice that have created a dice carpet. We have managed to get to significant milestones quicker than I expected. I did have high hopes for what I could achieve with my combo class channel and any of my bonus content on this channel. I did not expect the bonus channel would have 5 times as many subscribers as the main channel, and I didn't expect either of them would go this quickly. So I'm loving the journey. Thank you to everyone who's joined me. There's also a Discord and subreddit and stuff, although I've been quite bad about responding to things on those properly or promptly. I will try and get better at chatting with the community through those interfaces before long, but in general, if you want to chat with the combo community, there are things like a Discord server, which I didn't ever use as a non-technology guy until somebody recommended I create one for the combo classroom. And of course, there's a lot of good video content that you can just stay tuned on through YouTube, because YouTube is my favorite app of all time. Some people have asked, another frequently asked question is if I post content elsewhere, and not much, although I do have many followers on TikTok, just from having posted all the shorts that are on this channel on there as well. And I actually posted them on there first, so I do have a few fond memories of seeing through TikTok that people liked the style of my shorts and responding to comments on there way back in the day and such when I was first booting up the combo class about 2 years ago. Now, both of my channels on YouTube are less than 2 years old, and it's just super cool that we're already at these milestones with such a community building and such. And I have great plans for especially grade -3, which will be our next grade, but also for the next 8 episodes that are the remainder of grade -2, and whatever bonus content occurs between those. Because I do measure the amount of the way we are through a grade as we are going backwards. Another frequently asked question being, will we ever hit grade 1? No, you've already done first grade, I hope. We are going a different direction. And yes, perhaps there will be something along the lines of complex numbers in grades someday, but those are more likely to be a different form of art, such as a book or something. Now, as far as our grade structure goes, going backwards on our real number line, we are 8 episodes away from the end of grade -2 is how I'm measuring it. And that's because I want each combo class season of sorts, which are on the main combo class channel, to have what will look like 100 amount of episodes after the world shifts to base 6. Until the world shifts to base 6, it's going to look like 36 amount of episodes. So, in any case, we are 8 away from that, and the remaining episodes of grade -2 will include our next one, which is what I consider to be maybe the most underrated concept in number theory, known as integer complexity. One that will be one of our more history-based snack breaks, where we are going to do a snack break based around coconuts on a vacation I recently was able to take, and I interviewed some locals on a particular island about how they weave hats out of the coconuts, which, you know what? We're celebrating right now. We might as well be wearing our coconut hat. So this is the hat the local wove for me out of palm fronds, and in particular the fronds from the type of palm that makes coconuts. I think those are called palms. At least these are coconut ones. There are also date palms, which grow a lot of places like that type of biome, and which the guy said he sometimes weaves hats out of as well. I also interviewed his partner who chops open the coconuts with a large machete and got some great clips about the history of coconuts and these people's opinions about different things. When traveling somewhere, you must be, nice to the natural culture there. And I was traveling to the island of Kauai in Hawaii, which there are some, stereotypes of people of my background, like a random white guy from California, coming out to an island like that and being a sort of reckless tourist. And so you want to avoid that. You want to try and be somebody who embraces the culture and just talks to the people as humans within their culture and see what you can learn from that. And I was able to learn about the culture of Kauai, in particular, that one island, to a degree, at least the history of coconuts, through some really cool people who will make a cameo in a coconut snack break. There will also be an episode coming up about equations that are true in every base. This is another episode I've been planning for a while, and it was finally the right time to do. And by that concept, I mean, like, which bases is the phrase 1 1 times 1 1 equals 1 2 1 true in? So think about that if you want in advance to test your mind. Testing your own mind on things is very important and is even part of the next main combo class episode, is my journey to find this thing known as integer complexity that I will explain, that I stumbled upon myself from scratch just by wondering certain questions about numbers, testing out things manually up to a certain degree, and then using the online resource known as the OEIS, or Online Encyclopedia of Integer Sequences, where I searched a string of numbers that was what I called the cost of different numbers, and turned out to be known as the integer complexity of those numbers, and found out this very underrated concept and whatever else research had been done about it, and what it told me about all the hypotheses I'd made about this concept when researching it myself. Now, to answer any questions in the chat, somebody wondered if I've ever thought about adding a series of numbers together until you get a single digit can provide the answer whether it's divisible by 3. Oh, I think you mean, why is it the case that three-even numbers are the nickname we use in the combo classroom for multiples of 3, are precisely the numbers that in our system, if you add the digits, you get a three-even number. So, for example, if I wonder, is 57 divisible by 3? Well, 5 plus 7 is 12, and that's divisible by 3. So is 57. If you mean why is that the case, I've somewhat gone into that in one episode on the Combo Class channel called Why the Number Threeven Should Be in the Dictionary, a concept we will return to in grade -3even. And basically the answer is that in base 10, one less than the base and one more than the base get cool properties in addition to the base number itself, and one less than the base gets certain cool properties with digit sums, and 3 is a factor of 9, which is one less than the base we count in. So it turns out that 3 does that digit thing in 1/3 of all typical bases, like 2, 3, 4, 5, 6, 7, 8, those type of bases where you're using positional numerals in a similar way, but a different radix, you'd call it. In those bases, in 1/3 of them, three-even numbers have that property. And it's the ones where the base number is actually one more than some three-even number that makes 3 divisible by it. You can watch my episode about that and whatever I'll explain about that in grade -3 more if you want to see some more details. But that's a very brief idea of why it happens is because 3 is a factor of the number 1 less than the base we counted. So you can do the same thing with 9, where if I know a number's digits add to a multiple of 9 in our base, that number is divisible by 9. So let's say I wanted to know which numbers are singly threeven, not doubly threeven. If you were doubly threeven, kind of like doubly even would mean 4. Some people think doubly threeven should mean divisible by 6, but I think it should mean like doubly in terms of the exponent, like multiplied, like we are a layer of threevenness deeper. So a doubly threeven number I would consider to be a multiple of 9. So what about the singly threeven numbers that are not doubly or more threeven? Well, those numbers are the numbers that in our base, their digits add to a multiple of 3 but don't add to a multiple of 9. If you add the digits of the number and you're not at the answer, you can do it again. You can add the digits of that. Keep going until you're down to 1 or 2 digits and you know whether that is divisible by 3 and or 9, and you'll know if the original was. So thank you to whoever also just left a motivational comment about the comment being or content being great. Thank you. I appreciate it. Right now, we are just doing a casual live stream for the day where we are going to chat about a few questions and maybe investigate some numberation traits if people are interested. I have been researching particular things for a game I've been developing still related to what I call numberations, where we do something like ×2 or +5 or to the power of 2 or something. Essentially, a numberation could just be a function that takes a number and spits out another number, but it's mostly, in the context of this game, a function that takes a 2-digit number and spits out another 2-digit number. Whole numbers from 00 to 99. So counting 1-digit numbers as 2-digit or less, I suppose, because they have a leading 0, but numbers that contain a maximum of 2 digits when described as a whole number. So 00 to 99, we want functions that take some of these numbers and put out other ones. It's okay for a function to not work in this case for certain ones, like we want each one to have an inverse, where if I have 5 goes to 25 by multiplying by 5 or by squaring it, I want the reverse operation of whatever path. So I would want either a divide by 5 or a square root. However, we're not as worried about... Okay, I'll explain more about the numerations later. That will be if I want to actually calculate the paths of some of my final testing, of which exact mix of numerations I want to include with a particular goal, that is to have the starting number of a particular pile, for example 0 or 1, be able to get to every single number in the range, 00 to 99 in this case, apart from a single target number. And my goal was even for that single target number to be the number 31, because I found that there are many paths to 31 using 4 numerations. However, I wanted every other number from 00 to 99 to be accessible within 3 numerations from my start of 00 or 101. And we may investigate that later. If not, stay tuned, because when I'm bored in my spare time, I do work on mathematical card games sometimes. Now, somebody asked the number of the day. That's a great question. Now, I suppose the number of the day would have to be whatever next special number we're going to pass when we, on either of my channels. So we have passed 200,000 and 40,000 relatively recently on my 2 channels, and those are, in the big scale, insignificant numbers. Those are numbers that are base dependent and have way too many 2s and 5s in their prime factorizations. So let's look at whatever notable numbers may occur beyond this. And I'm not going to go too deep right now, but I will search a thing or two. I'm going to take control of the laptop here at the diagonal on the desk and be very careful not to drop it. And I'm just going to search for one, what does Wikipedia list when you have to go to the smallest, what you could consider a round number in our base below what you're looking at when you're at this size. So I'm looking at 100,000, and I'm going to see some special numbers they list in a range 200,000 to 299,999. I know I'm not showing this, but I will write the numbers if we find cool ones. And then I'm also going to search, and we're going to do a similar thing for 40,000 because that's where the combo class channel is at. Then I'm also going to look for one of my favorite types of numbers, which are known as highly composite numbers. And I'm going to see the next highly composite number we're going to hit on each of those. Highly composite numbers are numbers with more factors than any smaller number. And essentially the number 6 has 4 factors, and there's no number from 0 to 5 of the whole numbers that have that many. So 6 is highly composite. They are sometimes nicknamed anti-primes for that reason, because they are, instead of being the least divisible, the most divisible. And there are other metrics to calculate it, like highly abundant numbers and superior highly composite numbers. And don't worry, we will have an episode someday about superior highly composite numbers. But for now, let's look at just the highly composite numbers and know that a subset of them are superior. Now, the next one we'll pass on the combo class channel will be 45,360. That is the smallest number with 100 divisors. But we're a little bit away from that. How about on this channel? On this channel, also a bit away. Our next one is 221,760. The smallest number with 168 divisors. Those are all pretty far away from where we're at, so let's see what Wikipedia has to say about the 40,000s and the 200,000s. Well, about the 40,000s, we are going to pass 40,320 on the combo class channel before long, and that is a factorial. That is multiplying all the numbers from 1 through 8. It's 8 factorial. So that might be, so far that's our lucky number of the day, 40,320. And you want to know the special fact that Wikipedia decides to list, out of many facts about this number we could list, is that it's the smallest factorial that's not highly composite. And actually, I've investigated this topic further, and I have found proofs that it's the first of an infinite amount of highly composites that are not factorials. They stop being highly composite after the 7th one. So, factorials, if I multiply all the numbers from like 1 through 7, or 1 through 8, or whatever, and just multiply all those whole numbers, would it be the smallest, or would it be a number with more divisors than any smaller number? Well, for the first 7 factorials, yes, but the 8th one, it's not, and then it continues being not. So, 40,320 is our lucky number for the day. I may have to go grab some pens in a minute if I'm going to write it here. The pens, I think, are in my room in there. We also will be approaching a square pyramidal number, 40,425. We will also be approaching other types of cool numbers. 40,755 seems to have a lot of polygonal traits. Now, what about this channel in the 200,000s? We may have to wait for another 1,000 subscribers so that we can get to 202,717, which is that it is one of the types of number, which I was like, this sounds really cool. So I looked at the link, and it's on the OEIS, the same place that I'm going to be citing in my next episode of how I found the name integer complexity back in the day. Here, this is A111441 on the OEIS is numbers k such that the sum of the squares of the first k primes is divisible by k. And this is a really interesting sequence. I might have to make a short about it or something. It goes 1, 19, 37, 455, 509, 575, 20,597, 202,717, which is the next one we'll pass on this channel in terms of subscribers, and then a large one that is over 1 million. So that's a cool sequence. Might have to make a short about that or something sometime. But those, I guess, are our numbers of the day. But if we have to pick one, we're going with 40,320. And when I run inside in a moment to grab some water, I'm going to grab some pens as well. And we'll write that on the board as our lucky number, because I do appreciate the reminders of having a lucky number for the stream. Gives us a fun backdrop. Now, somebody is saying that the best primes are with highly composite numbers, and they express a fraction of 137 over 60. I'm not sure exactly what you mean by that. Feel free to give more details if you are curious about any details about that. Other people wonders, let's see, it's hard to read. Okay, someone else wonders why the divisibility trick with 7 works, where you double the last digit and subtract from the rest. Well, sometime I'll make an episode about the divisibility tricks all the way up to 20 or 30 and what they mean about our base. But really, it's just because 7, it's its relationship to our base number that causes that. And 7's weirder than the other divisibility tricks because it's co-prime to the base number. 10 and 7 have no factors larger than 1 in common. And every other number on the way to 10 is either shares a factor larger than 1 with 10, or 1 less than the base, which, like I mentioned earlier in the stream, has cool properties often. And since all the other numbers apart from 7 up through 10, all the whole numbers, either have a factor in common with 10 or 1 less than 10, and we count in base 10, 7 has the weirdest of the divisibility tricks. But you did ask sort of more like, why does it work still? Well, there's almost always going to be some divisibility trick that works. It's just going to be a harder one when a number does not share factors with the base, or the number 1 smaller or greater than the base, or things like that. We'll go into more details in some future episode about that. Somebody also just said the harmonic sequence, and that it does often have primes mixed with highly composite numbers. The harmonic sequence is very beautiful. We did a bonus video on this channel that mentioned it once, and we will at some point return to that concept, because there will be an episode on my combo class channel in grade -3, probably maybe in the remainder of grade -2, that will be about my favorite infinite sequences that converge onto strange things or diverge like the harmonic series does. Now, thank you to everyone who is joining at the moment. I am going to run inside to also grab some nuts for the squirrels that those sounds might be, to grab myself some water, and to grab some pens to write on the whiteboard. I'll be back within a minute or two, and maybe you will see a squirrel in the meantime. Who knows? Alright, folks, so. Oh no, my blueberries are spilling. Now, these aren't an example of it. These are normal sized blueberries, but I said I thought they were making the berries bigger these days, and I swear they are. And I'm all for it. I gotta show you these jumbo blueberries next time I get them. They're making these things massive nowadays. And I can't wait till I can eat a blueberry with a knife and a fork. Let's go. Now, our lucky number for the day is 40,320. Somebody asked what is the lucky number, and I like having one of those. That is the next amount we will pass on my main combo class channel. Right now it's at like 40,050 or something like that. And this is 8 factorial. And it is the first factorial of an infinite list that are not highly composite compared to 1 through 7 factorial. This means multiplying 1 through 8 basically results in 40,320. It also can be considered the amount of permutations of 8 items. Like if I have 8 clocks, which I do, then it's the amount of ways I could order them on the shelf there if I put them all on the shelf on some order. So, thank you everybody for joining me, and as I noted to the earlier folks before our brief break, this is somewhat of a Q&A and somewhat of a frequently asked questions versus freshly asked ones, and somewhat just a celebration of our channels passing bigger milestones than ever expected in a shorter period of time than ever expected. So, to anyone joining, feel free to ask any questions or thoughts. Now, in the meantime, we do want to possibly discuss, or I want to possibly discuss at least, some of the investigations I've been running for the game I've been designing with my numberations and the mathematical version of what that could tell us. I've been looking at paths from the number 0 or possibly 1 over to the number 31, but I've been looking at a range that ranges from 0 to 99. All of the numbers that can be expressed as 2 digits or less as some integer without a negative sign. And my goal was to make every single number from 0 to 99 except for this target number or some other target number I may discover be accessible in a fewer amount of total cards you would play. In this case, if we're looking at the cost of a certain thing, we sort of get shortcuts. Like there might be cards that are times 2 or times 3 or times 5. However, we can only play a times 5, although it expands things larger on a more limited amount of them. Similarly, there would be a divided by version of each of these, and each thing should have an inverse in the original version of the game I'm designing, and they should be bijective functions essentially in a certain way, but they don't have to be bijective throughout the entire range. They can have a particular range in like the sense that this, let's look at times 5, can multiply any number from 0 through 19 it could hit and result in another number in that range. Divided by 5 also has the same amount of numbers it can hit, but they're the times 5 versions of the 0 through 19 that could hit. So in this game, my goal was at the moment to make this take 4 cards to get to. And so I definitely had these. Some versions had times 4 and divided by 4. Those were one of the optional ones I was wondering about whether I would include or whether I would just do primes through 5. And I was also looking at adding and subtracting one. These are different cards, the add and subtract ones, but I'm making it look like plus or minus. 1, 2, 3, 4, and maybe 5, and the 5 is dependent on which of the starting numbers I have one of the piles be. Now, since things work in reverse, you're actually able to play on either pile. You're able to go ×2 on the 31 or +3 on it or whatever. But it still will take, if it takes 4 numbers or 4 cards for me to get from one of these to here, then it will take 4 total cards for either path to reach each other, because there's a symmetry in the way I've designed it. And some things are self-symmetric, like some are their own inverse. For example, if I include this, I was also going to include one that was 99 minus n. Now, this is different than n minus 99 or n plus 99. N is the current amount on a particular stack you played on. 99 minus n is like the difference between 99 and the current number on some pile. And if I had this one, I was going to do 100 minus n. Now, why was it particularly 100 there and 99 there, even though that's a bigger difference? Like, you can't even play that to start 100 minus n until you change that pile. You could play it on that and get a 69. Nice. But, or this one, you could start off with like a 98, or you could play it on that and get like a 68. But the reason I did this is because I didn't want either of the piles that starts here to be able to get to 99 on the first step. Otherwise, we could hit it with a divide by 3 and then a -2, and we'd be at our target in 3 numerations. I often want to think of them as numbers, but we'll call them numberations is the nickname I've given, like the little combo of a operation and number. Now, in addition to these, I also thought, well, if we're going to do something minus the number, maybe we should have some that are something divided by the number, like maybe 360 over n, or 240 over n, or stuff like that. But I do be careful about which ones I included or didn't include out of these possibilities, because whichever ones I include could make the path go too quick, or might not even help me enough in my goal of making every other number in this range accessible in only 3 of the cards, as opposed to 4. Now, this is just something I'm playing around with, but if anybody wants to do any research on their own and let me know in a comment here later, you could feel free to let me know with this target number or any other target number, including the set of these, and let me know if you include the 4s or not. The set of these, and the 5 is dependent on whether we're starting from 0 or 1. Probably that for a minus. And one of these divided bys. Can you find a good one that lets us hit every number apart from the target? Now, the other goal is that the target number is relatively low, because, I mean, it looks here, because it's not to scale, like it's all the way over there, but 31 is less than a third of the full range. And I want it to be low because people know the factors of the nearby numbers more. And since it's a prime, you got to approach it. You got to go somewhere near it and then hit it with a plus or minus. Or go to a multiple of it and then hit it with a divided by. Or go to 13 and hit it with a digit flip, or what I was thinking of as a reverse, which switches the 2 digits of the base 10 representation of the number. We are stuck in base 10, so to make the game understandable to people, we're letting it be base 10. So that would mean that if that is a card, I consider it in this version of it a zero-less reverse, because I didn't want to let this flip to 10. It made things too easy. I could add 3 to that or 2 to that, and then flip it to 30, and then add 1. And so it was the zero-less reverse, in a sense, I was adding, that you need a number that's 2 digits that don't include a 0, and it flips them, their base 10 representation. So you can get to 13 and then use a reverse card on it. This still hasn't broken it. All the things we've added, apart from maybe, depending on which of these combos we do, that this will take 4 paths. And almost all of these numbers, if not all of them, will take 3 apart from it. So, let me know if anyone wants to work any thoughts about that. I want the divide bys and the minuses to be sensible. So, or if we have more pluses, I considered a plus 20 is a helpful operation, or a plus 50. But you can't do both, actually, because first I thought you could, but when you do plus 50, then the inverse of plus 20, which we want them each to have the inverse, so it's minus 20 is available. Plus 50 minus 20 gets us to 30 in 2 moves, and then we just add 1. So it's hard to make this the only number in the range that's not accessible. There's ways to do it, like if I did 0, 0, 100 minus n, 100 divided by n, and 360 divided by n, and all these, and square root, so to the power of 2, and n to the power of 2, and square root of n, we'll write it as. If you have all these, and we went with that, you start from 0, 0, and 3, 1. And you have 100 minus n available, 100 divided by n, and 360 divided by n. I think you'd be able to hit everything but 31. Those were some brief tests I was doing, but I'll do further tests on my own later when I'm bored. And also, anybody who happens to be a programmer or whatever could maybe run them even quicker. Now, somebody mentioned lucky numbers are pretty cool. And they are. I've done a short about those, not a full episode yet, but I do find it funny that there is a mathematical thing called lucky numbers that includes both 7 and 13, which in the modern Western culture I live in, 7 is considered lucky and 13 is considered unlucky. And so they're both technically lucky in a mathematical sense under that one term. So, thank you to everybody who has joined so far. These are some notes that I could fiddle around with more, but it's a little easier to do on my computer. I do also want to jump to figuring out how I'm going to film the rest of my integer complexity episode. I have a few more cutscenes and explanations I need to fill in, and I have lost my phone, unfortunately. So, I'm working on that. There have been some issues in grade -2, but we have still gotten to these great milestones of subscribers. Make sure all of you are tuned into the Combo Class channel as well, so that we can get to our lucky number and beyond and such. And so maybe we can even surpass the 5-to-1 ratio of how many people are on my bonus channel to my main one. However, in any case, I love making these streams and bonus videos. I'll see you again soon for some shorts and for the integer complexity episode that I will somehow finish. And see you for some other types of content on this channel as well. Thank you all for joining me, and I think I might wrap up soon. I can work on trying to film and edit the rest of that episode, so hopefully it will be out tomorrow on the Combo Class channel. It'll be 30 or 40 minutes, and it's about what I genuinely think could be considered the most underrated concept in number theory. So, until later, make sure that you have all of your axes correct, otherwise things might slide on you. And I love all of you for watching and for being part of my Combo Class program. Got some cool plans for the rest of grade -2 and whatever grade -3 turns out to be. And I love you all. I'll see you again.